Hey guys, this is test 48 game 1. This is the electrical appliances game. It's an in-out game, also known as selection. We know that because they're telling us all about which appliances cannot be used simultaneously. So some can be used together and used means in, others cannot be used together and not being used means out. So it's an in-out game here. We've got lots of conditional rules. Now they might not appear to be conditional at first glance, but they actually are. The first rule telling us, for example, that H and R cannot be used together means that if H is used, then R is not, and vice versa. So if H is in, then R is not, contrapositive. If R is in, then H is out. Next, they tell us that H and T cannot both be used simultaneously. So if H is in, then T is out, contrapositive. If T is in, then H is out. Next, if V is used, then none of H, R, or T could be in. So, if H is in, then V is out. Contrapositive, if V is in, then H is out, of course. And then V also leads to not R and to not T. So, either T or R being in could lead to V being out. So, lots and lots of conditional statements here. But that basically is what the game is giving us, so that's what we got to deal with. I know that there's a little bit of repetition here in each diagram with not R and positive R, not R, for example. These two big messy chains are the contrapositives of each other, and despite the fact that they're messy, it's still okay. We'll be able to solve the game without too much trouble. It actually isn't that bad. Now, question number 1 is just simply asking us what's a pair of appliances that could be used simultaneously. So of course H in leads to R out, so A is gone. H in leads to T out, so B is gone. R leads to T is out. Is that true? No. R and T do not have a relationship where one in leads to the other out, so C is good and is our answer for number 1. I will look at the rest though. V in does lead to R out and R in leads to V out, so D is gone. And then E, T in leading to V out, yes. T here leads to V out, and V here leads to T out, so E is gone as well, leaving C by elimination for number 1 if you didn't get it before. Next, number 2, if Henry, the guy here, uses 2 appliances exactly and not M. So I'm going to make a little in-out table here, in the left column, out in the right column. If M was out, and there were exactly 2 appliances used. So because of this, we know that H and V both have to be out, because if either H or V was in, we would be losing R, T, and V as well, and then we wouldn't be able to have exactly 2 things in, since M is already out. If H was in, we would lose R, T, V, and M. If V was in, we would lose H, R, T, and M, and then we would only be able to have 1 thing in, because remember there are 5 things total. So H and V have to be out, and so for that reason, choice E is our answer to number 2, simply listing both H and V out. Next, number 3, what cannot be true? So 4 of these things could be true. You could find the 4 could be trues, eliminate them, and whatever remains will be your answer, or if something jumps out at you, obviously just pick it. So could we have H and M? Yes, M is not involved in any rules at all. It's ambiguous. So for that reason, yes, H and M could be in together, and A is gone. Could M and R be together? Again, M has no rules about it, so B is gone. C is gone for that reason as well. Then T with 2 others. T in simply leads to H out and to V out. So T could not be with either H or V, but T could be with M and R. So yes, T could be with 2 others, and D is gone, leaving E by elimination for number 3. And if you look at it, V with 2 others, V conflicts with H, R, and T. So for example, if you had an in-out column here with V in, H, R, T out, if V could only ever be with M, that's V with 1 other thing, not 2, and that's all 5 people, 5 things. So for that reason, E is our answer to number 3. Next, number 4, if he uses exactly 3 appliances. So if he's using 3 appliances, we can't have either V or H, because V and H lead us to lose at least 3, and then we wouldn't be able to have 3 because there are only 5 things. So V and H both have to be out for certain here. What's the total number of different groups of 3 things that could be the group of appliances? So if you have 3 things in, how many different combinations of 3 things could you have? Well, only one, because the only things you could have in would be M, R, and T. This is the only possible combination that allows you to have three things. So there's only one possible layout, so therefore 1, choice A, is our answer to number 4. Next, number 5. What would guarantee that you have no more than one of H, R, or T? Well, if there's a conflict between them, of course, H in leads to both R and T out. So if you have H in, again, in out table, if H is in, you lose both R and T. So having H in guarantees that you lose both R and T. So choice A is our answer to number 5. I will look at the rest though. Having T in guarantees that you lose H. So that would guarantee that you don't have all three, but you could still have both T and R in. So for that reason, it wouldn't guarantee that you have only no more than one of those. So B is gone. Looking at C, not H doesn't lead to anything. There are no arrows stemming from not H going forward to something else. You could still have both R and T, so C is gone. Looking at D, not using M. M's not involved in any of the rules at all in any regard, so that guarantees nothing. Then looking at E, not using V. Not V doesn't lead to anything because there are no things stemming from that variable being negative, so E's gone as well, leaving A for number 5. Next, number 6, general must be true question. So we'll just run through the choices. Looking at A, at most 3 things simultaneously. Yes, because there are only 5 things total, and 2 of those variables, V and H, lead you to lose 3 other things. As we said before from question number 4, if you have 3 things, that would be M, R, T, and then you can't ever have 4 things in because H and V pose problems. They require other things to be out, and they each require 3 things to be out. So you can't ever have 4 things in. You can having either of H or V in guarantees that you will lose at least 3 things. So A is impossible. Sorry, having more than 3 is impossible. So A is our answer to number 6. I will look at the rest though. B having at most 4, like I just said, 4 is impossible due to H and V requiring too many things out. Looking at C, at most 1 other thing with you when using M. As we see right here from this diagram, you could have M with both R and T, disproving C. Looking at D, at most 1 other thing while using R. As you see here, R could coexist with both M and T. It simply conflicts with V and with H. So D is gone. And then looking at E, at least 2 other things with H. H could only be with M due to the fact that it conflicts with R, T, and V. So E is gone, leaving A for number 6.